Let's begin our journey into the world of graph databases. In this video, we will explore connected data with graph-based NoSQL solutions. Graph databases are NoSQL databases that use graph structures to store and query connected data. In a graph database, nodes represent entities, for example, a user or a post. Edges represent the relationships between these entities. For example, a user created a post, and properties store metadata, such as the user's name or the post's content. Graph databases are composed of three key components: nodes, edges, and properties. Nodes are the entities or objects in the graph. Edges represent the relationships between nodes, showing how they are connected. Properties are key value pairs that store data about nodes and edges, providing additional information. Let's compare graph databases to relational databases. In a relational database, data is stored in tables with rows and columns. Each table has a primary key, and relationships between tables are established using foreign keys. In a graph database, data is stored as connected nodes and relationships. Each node represents an entity, and each edge represents a relationship between two entities. This structure makes it easier to represent and query complex relationships. Here are some popular graph databases you might want to explore. Neo4j, a native graph database, uses the Cypher query language. Amazon Neptune is a fully managed graph database service. OrangoDB is a multi-model database that also has graph capabilities. Finally, JanusGraph is a distributed open-source graph database. Graph databases have many real-world applications. Social networks use graph databases to manage friend connections and provide recommendations. Recommendation systems use them to suggest products and content. Fraud detection systems use graph databases to recognize patterns in transactions. And knowledge graphs use them to represent semantic data relationships. Let's look at a Cypher query example. Cypher is a query language used by Neo4j. The code block shows a query that matches person labeled as person, who are friends with other people also labeled as person. It filters the results to find friends of a person named Alice, and then returns the names of those friends. Visually, Alice is connected to Bob by a friend's relationship, representing the query result. Like any technology, graph databases have both benefits and challenges. Some of the benefits are fast relationship queries, intuitive data modeling, a flexible schema, and pattern matching. Some of the challenges are a limited tooling ecosystem, a learning curve for teams, scaling complexities, and memory requirements. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.